Buddy, and welcome to Dakota Test Prep Question Walkthrough. In this video, we're going to talk about motor overcurrent. Now, I'm well aware that you would rather be doing anything else but this, but unfortunately, you are doing this, so let's suffer through together. What is the maximum size non-time delay fuse allowed protecting a 30 horsepower, 600 volt, three-phase squirrel cage motor with a service factor of 1.15 that is operating under normal circumstances? My friends, my beautiful friends, if you've seen any of the other videos, you know exactly how we're about to start. If this is your first video, strap in. The first thing we ask ourselves is, what is the question asking for? Ooh, red. What is the question asking for? In this case, it is asking for overcurrent. Overcurrent. Now, which type of overcurrent? Specifically, when it comes to motors, the type of overcurrent matters when it comes to hot motors. This question wants non-time delay fuse. Now, hopefully you all remember, but if you don't, that's okay. Overcurrent for motors is a table 29. So we're going to be using that bad boy. What is the question asking for? Overcurrent. What information do we have? We have our motor info. The reason it's so important to always do the same thing, what is it asking for? What do we have? What do we need? Again, is because the CFQ really wants to mess you guys up. It's going to give you more information than what's necessary. So it's up to you to pick out specifically what you need for what the question is asking for. In this case, it's mentioning service factor. Do we care about service factor when it comes to overcurrent? No, we don't. Service factor only applies to overload. So we don't care about that. Just ignore it completely. What's the question asking for? Overcurrent. We have our motor info. Beautiful. What do we need? We need our flaw. Now, flaw in this case, because it is three-phase, is we're going to head over table 44. Boom. It said it was 575. And it said it was 30 horses. So we end up with a flaw of 32 amps. Beautiful. Then we head over to table 29. That's our overcurrent table. It said it was a squirrel cage motor, non-time delay fuse, which gives us a 300% multiplier. So we multiply this by 300%, same thing. So we're going to do the math on that, and we end up with 96 big, fat, juicy amps. Well, that's great. Look at how easy this is. Well, guess what? As soon as we're done there, what do we have to do? We actually have to size the fuse. What table do we use for that? Table 13. Table 13. And for everything motors, we always go downtown. Things will be great when you're downtown. Boom, 90 amp, non-time delay fuse. And for anybody who is wondering, that song, it's called Downtown, and it's by Petula Clark. Petula Clark. Quite a songbird. Look her up, she's great. Anyway, the whole point to all that, what is it asking for? Overcurrent. Which overcurrent? Non-time delay fuse. Table 29. Boom. What do we have? In this case, we have our motor info. What do we need? We need our flaw. Table 44. Boom. What are we going to do? We're going to take our flaw. We're going to use our multiplier. We're going to find our big, fat, juicy amps right there. And then when it comes to overcurrent for motors, we're going to sing our song. Downtown, things will be great when you're go downtown. We're going to head over to table 13. Bam, 90 amp, non-time delay fuse. What else are we going to do? We're going to ignore all the extra stuff they gave us because we don't need it. And that, my friends, is how we calculate motor overcurrent.